Alright, welcome back. In this lesson, we are going to be solving this equation of circle. We are required to determine the area of the largest rectangle that can be inscribed in the circle. Of course, we know that this is not the general form of a circle. However, it's also a circle. But then I'll be showing you very quickly what you need to do in order for you to get the area of the largest rectangle that we can inscribe in this circle. So let's just quickly dive into that quickly so that in no time we arrive at the solution. Now this is the equation of the circle that we were given: x squared plus y squared equals a squared. But we know that the general form of the equation of a circle is something x minus g all squared plus y minus h all squared equals r, where g and h, g comma h, represents the center coordinate, that's the coordinate of the center. Now what this means is that whatever the value of g and h is, so long you have an equation that you can express in this form, whatever the value of g and h is, that will be the coordinate of the center, where g represents the x coordinate and h represents the y coordinate. Now if g and h, if they are 0, meaning that the circle actually originates from the center, and then this particular expression can now become x minus 0 all squared plus y 0 all squared equals r squared. So this is actually for a circle that originates from the center, that is, from the origin, that is from point 0. So if we simplify this, we now have x squared plus y squared equals to r squared. Now look at the original equation of circle that we have: x squared plus y squared equals to a squared. So if you compare this, you'll say that they are similar. The only difference is just this r and this a. So if every other thing appears the same and it's just, so that means that when we relate them, so we can see that our r for this particular circle, our r is the same thing as our a, where r is the radius of the circle. So it means that the radius of this circle is actually a. So now let's do the sketching of the information that we have. So here we are. This is our y-axis. This is our x-axis. Now, we've been able to show that the radius of the circle is a. So we have from the origin to the circumference to be a. Then this is x-axis, so this will be x. This will be x. This will also be x. This is y-axis. This will be y, and this also will be y. So if we add up the length and the breadth, it means that for the length of that rectangle, we have to draw the rectangle around the circumference, where the radius is actually our reference. Now the length will now be 2x. By the time you add up this x and this x, that will give us the total value of the length. Then we have the breadth. The breadth to be 2y. And don't forget area of rectangle. Area of rectangle equals to length multiplied by breadth. So if we do this, we have 2x multiplied by 2y, and this will give us 4xy. So the area of this rectangle is actually 4xy. Now, we've been able to deduce the value of the area of the rectangle in terms of x and y. We're given the equation of the circle to be x squared minus x squared plus y squared equals to a squared. So if we make y the subject, we have y squared will be equals to a squared minus x. Then y equals to square root of a squared minus x squared. But initially we were able to deduce that the area of the rectangle is 4x. Let's call this equation 1. Let's call this equation 2. So we can put equation 1 into 2. So when we do that, we have the area of the rectangle to be the same as 4x. Then when you see y, you now put square root of a squared minus x squared. Now there's something we can do from here. We can decide to find a way of bringing this 4x into the root. And in order for us to do that, all we just do is to just take the square of this, then we can now bring it into the root. So the area will now become 4x squared and a squared minus x squared. Then when we simplify further, 4x squared will give us 16 squared into a squared minus x squared. Then we can expand that so that we have 16 squared a squared minus 16x 4. Now this is the area of the rectangle in terms of x. Square root of 16x squared a squared minus 16x raised to power 4. Now the next thing we want to do now is, from the question we have to find the greatest area, that's the maximum area of the rectangle that can be described in that circle. Now invariably what we have to do is to actually find the maximum point, and as part of the application of calculus, if you are finding maximum and minimum point, the first thing you need to do is we need to find the critical point. And at critical point, the condition is that at critical point, the derivative of that function of the zero. So the first thing we need to do is we need to find the derivative of this with respect to x. Then once we find the derivative of all of this with respect to x, then we can now find the value of x at critical point. Because at critical point, the derivative becomes zero. So now let's quickly go ahead and differentiate this area that we have. Now, how do we go about that? We have a equals to square root of 16x squared a squared minus 16x4 x to the power 4. So we need to find the derivative of a with respect to x. Now let me quickly transform this from root to another form. To become 16x raised to the power 4 a squared minus 16x4 raised to the power of 1 over 2. Now this is function of function, and if you want to differentiate function of function, this is how you go about it. So we have the derivative of x with respect to x. Derivative of a with respect to x. So the first thing you do is differentiate this normally first by bringing down your 1 over 2, then subtract 1 from the power in this. So when you subtract 1 from the power, it becomes minus 1 over 2. So that you have raised to the power of minus 1 over 2. Then you now multiply by the derivative of what you have in the bracket. That's why we call it function of function. You differentiate normally first, bringing down the 1 over 2, bring down 1 over 2, then subtract 1 from the power, then you can now differentiate what you have in bracket with respect to x. So when you differentiate what you have in brackets, that will give us we have 16x. Sorry, this is not x raised to the power 4, this is x raised to the power 2. Let's not make that mistake. So when you differentiate what you have in the bracket, automatically you have, let me change this to 2x raised to the power 2. Then we have 32x a squared minus 64 x cubed. So that's what you have. Then we can now proceed further in this. So when you proceed further, this becomes 1 over 2 multiplied by 32x a squared minus 64 x is plus 3 divided by square root of 16 squared a squared minus 16x x is plus 4. So from there we can continue our simplification in this form. So this will give us 1 over 2 multiplied by we can factorize 4 out, or let's just factorize 8. We can bring 8 out. So we have 8 into 4x a squared minus x cubed divided by, we can bring 16 out here, so this will become square root of 16 into x squared a squared minus x. So from here, a prime of x is equals to 8 into 4x a squared minus 8 cubed. So from here, this 4 will divide this 8, so to 2, and these 2 will cancel out this 2. Then we can now say that a prime as derivative of a with respect to x will now be equal to 4x squared minus x cubed divided by x squared minus x. And the next thing we do now is, since we are looking for the maximum point, that's the maximum area of the rectangle that can be inscribed in that segment. So it implies that we need to find the value of x at the critical point. So at critical points, a at the root of x will be equal to 0. So from here we can now say 4x a squared minus x cubed divided by x is minus x equals to 0. So let's just multiply. Then we have 4x a squared minus 8x cubed equals to a squared minus x4 multiplied by 0. Then we have 4x squared minus equals to 0. And from here we have 4x equals to 8x. Divide both sides by 4x. Divide both sides by 4x. So we have over 4 over 4x. This 4 will take out this 4. This x will take out this x. Then we have a squared equals to this 4 will take out, divide it, and will be left 2. This x will take out one of this x. So we have a squared equals to 2x squared. Then we have x squared equals to a squared by 2, because our interest is to find x. Then from here we can say x equals to square root of a squared over 2 is equal to a over 2. So that's the value of our x. So in addition, we were able to make y subject. That we said y equals a squared minus x squared. And now we were able to deduce that x equals to a divided by root 2. So if we put, let's call this equation 2 or equation 3. Let's call this, the other time we'll call this equation 2, I guess. So can I say put equation 3 into 2. So if we do that, we have y equals to a squared minus a over all squared. So then we have y will be equal to square root of a squared minus a squared. When you simplify this will give us square root of a squared over. So in like manner, y is also equals to a divided by root 2. So at critical point we're able to get the value of x to be a over root 2, and also the value of y to be a over root 2. And don't forget, at the beginning we said the area of the greatest rectangle is actually 4x. So now that x is a over root 2 and y is a over root 2, let's substitute those values here. So put x equal to over root 2 and y also equals to a over root 2. So then we have a will be equals to 4 multiplied by a over root 2 multiplied by a over root 2. So when you multiply this out, we have 4a squared divided by root 2 multiplied by root 2 will give us 2 divided by 2. So 2 here 1 here 2. Therefore, the area of the largest triangle 2 is square units. Square units. And that's now the question is, why do we have to make use of the area around the radius of the circle? I mean, why do we have to make use of the rectangle that surrounds the radius of the circle? That's just very simple, and that's because for you to form a rectangle from any circle, the greatest distance that you can get is actually from the center to the circumference of the circle, and that rectangle that you're looking for will actually be enclosed around the radius. So that's why we have to do it around the radius. And by the time you follow all those two processes, eventually arrive at the greatest, the area of the greatest rectangle that is required. So for whatever value of a, the area of the rectangle that we are required to find is actually 2a squared. Please do not forget to like this video. Do not forget to subscribe.